This is the lesson video for section 1.6, which is going to wrap up our unit. This is on exponent laws and the order of operations. We're going to do the get started here just to review the order of operations. If you feel like you already remember BEDMAS and what the order of operations is, you can skip ahead a few minutes and skip ahead to the examples. But just to remind everyone who needs it, BEDMAS helps us remember the order in which we want to do operations when we're evaluating a mathematical expression, and we want to go in this order. I like to write it actually up and down. So B, E, we'll start with B and E. So B stands for brackets. So anything in the brackets you want to do first. E stands for exponents. You want to evaluate all exponents second after you do the brackets. And then what's important is D and M, dividing and multiplication, come at the same time, and you do it in the order in which you read. So from left to right in the equation. So you might actually do multiplication before you do division if the multiplication comes first in the equation. And then same with adding and subtracting. Again, it's in the order in which you read. So if there's both adding and subtracting in the equation, you would do it from left to right as you read the equation. Okay, so just a couple of examples here. I'm going to do this one and this one. So here we see that there's some brackets, so I'm going to do that first. And when you're writing your solutions here, you want to write it step by step, writing only one equal sign per line, and you write out the entire equation and only change the part that you've evaluated. So this would be 6. Now we want to do the multiplication and the division, and we're going to do it in the order in which we read. So we're going to do the multiplication first. So this would be 6 times 2, which is 12. Now we're going to do the division. 12 divided by 6 is 2, and then finally the addition. Okay, let's do the next one. We've got some brackets here, and inside the brackets you still need to do BEDMAS. So we're going to evaluate inside the brackets, and we'll do the exponent first. So 3 squared is 9. And we'll keep working inside that bracket. 5 minus 9 is -4. Again, one equal sign per line and evaluating one operation at a time. -4 squared is 64. Now we're going to do the order in which we read. So multiplication and division, they happen at the same time. So we'll do the multiplication first because we start on the left. So that's 192. And 192 divided by 4 is 48. There we go. Okay. We are also going to be applying the order of operations to exponents today, and the exponent laws as well. Okay, so let's just go ahead and do, so here again is BEDMAS, and they say the same thing, multiplication and division in the order they appear, which means from left to right, and then same thing here. Okay, so check your understanding. Number 1 says, write each expression as a single power. So we're going to use the exponent laws to make it as simple as possible, and then we're going to evaluate it. So you can look at some of their examples as well to see some more. We're going to do example A and B, and then if you would like to, you can try C on your own. The answers are down below. So I'm going to use a space above it, just because there's not too much space below, to do example 1. Sorry, my light's turned off. Let's turn it back on. There we go. Okay, so example 1A says 2.5 to the power of 3 times 2.5 to the power of -5. Now, we don't want to start evaluating right away because we can make this a lot simpler. These have the same base, and so exponent law number 1, the product of 2 powers with the same base, says we can add the exponents together. So this would be the same as 2.5 to the power of -2, since -5 plus 3 equals -2. Add the exponents. Okay, and whenever we're dealing with decimals, we want to change them to fractions. It's a lot easier to apply the negative exponent. So 2.5 is the same as 5 over 2. And now we want to evaluate this. So negative exponent, remember that means you want to divide by the number twice. So we want to flip it. So it'd be 2 over 5. all squared. And 2 over 5 squared is 4 over 25. 2 times 2 is 4. 5 times 5 is 25. Most calculators will allow you to check this as well, so you could double check your steps there and see if you're correct. Okay, let's do B. So B is a little bit more complex, so we're going to apply 2 exponent laws this time. So we have 5 over 6 squared, and then that's all to the power of 7. And then we have, same again, 5 over 6. So because these are the same base, we're going to be able to combine these. And then that's all to the power of -4. So we don't want to start evaluating just yet. We want to make this into a single power using our exponent laws, and then we want to eventually evaluate. What you want to do is kind of work within the brackets first, because BEDMAS says work with brackets first, and then we'll combine them separately. So first thing we're going to do is apply that power of a power law. We have kind of a double exponent here, so we can multiply them. So this would be 5 over 6 to the power of 14, since 2 times 7 is 14. And this would be 5 over 6 to the power of -12, since 3 times -4 is -12. And now we've got a product of 2 powers with the same base, so we get to add the exponents. So I'll put here multiply exponents. Now we're going to add the exponents. And so that would be 5 over 6 to the power of 2, because 14 plus -12 is 2. And finally, we get to evaluate. You want to use the laws to make it as simple as possible, because then it's much, much easier and less work to evaluate at the end. 5 times 5 is 25. 6 times 6 is 36. And that's our answer. Okay, so if you would like, you can try question C and check your answer down there. All right, let's go to example 2. It's going to be the same idea here, but it's just going to be a little bit more work. Okay, so have a look at these examples. We have some rational exponents here, but it's the same idea. We're going to simplify it as much as possible and then evaluate. So I'm going to use this space up here. I'm going to be doing 2A and 2C, and then if you want to try B and D on your own, you may do so. Okay, so 2A, there's a lot to write down here. 36 to the power of 7 over 8, all over 36 to the power of 1 over 6, times 36 to the power of 11 over 12, or sorry, 11 over 24, and then that's all squared. Okay, so my tip for you is to, whenever you see any fractions that can be reduce fractions whenever possible. If you don't reduce, this problem is really hard. I tried it without reducing. It gets really tricky, but if you do reduce whenever you can, it makes it a lot simpler. So that's my tip for you for questions like this, especially where there's lots of different fractional powers. Okay, so first thing we're going to do here is work inside the brackets, and we're going to combine the 2 powers in the denominator there, because we have a product of powers with the same base. So we can add the exponents. And when we're adding 2 fractions, we have to recall that we have to have the same denominator. So 1 over 6 can be turned into 4 over 24 in order to add those 2 numbers together. So this would be the same as, I'm going to leave this up at the top. So 4 over 24 plus 11 over 24, that would make 15 over 24. Now here's where I can use my little tip. 15 over 24, we can reduce that, and we should. If we don't do it, then it's going to make everything harder. So 15 over 24, it reduces if you divide by 3. Divide by 3, we get 5 over 8. So let's rewrite this. So it'd be 36, 7 over 8, divided by 36, 5 over 8. That makes our life a lot easier, because notice the 2 denominators here are both 8 now. It's going to be a lot easier to subtract them. So that's what we're going to do next. We're going to apply the second exponent law. We're dividing 2 powers with the same base, so we get to subtract the exponents. 7 over 8 minus 5 over 8 is 2 over 8. Look how simple it's already looking. And again, we can reduce this. 2 over 8 is the same as 1 over 4. So again, you always want to reduce fractions if you can, even within the question. Don't wait till the end. And now finally, we have a power of a power. So we are going to multiply those together. 1 over 4 times 2 is 1/2. And there we go. Now we can evaluate it now that it's a single power. Recall that powers of a half are the same as a square root, and the square root of 36 is 6. There we go. So something that looks quite complex, using the exponent rules, we can simplify it down and then evaluate it without even using a calculator, which is pretty cool. So that's why the exponent laws are pretty useful. Okay, let's go and do 2c. Let's see where I have some space here. I've got some space up here. I'll go here. So again, you can try B and D on your own if you like. So C says 5 to the power of 1/3 times 3 to the power of -1/2. And that's going to be all to the power of 6. Now, inside the bracket, we want to do inside the brackets first if we can, because BEDMAS tells us that. However, notice these have different bases. So we actually can't apply that law that says to add the exponents because those bases are different. That's important to know. So we cannot combine those together. The only thing we can do here is apply the power of a power law and apply that power of 6 to both terms on the inside of that bracket. And so we're going to multiply the exponents. So we'll have 1/3 times 6, and we'll have -1/2 times 6. Both of those work out to be whole numbers. 1/3 times 6 is 2, and -1/2 times 6 is -3. Okay, so let's evaluate those. 5 squared is 25. And remember what the negative means? It means you want to flip the number. So it's going to be 1 over 3 cubed, which is 27. And you can write it as just one single fraction, 25 over 27. There we go. That can't be reduced. So that's our final answer. Okay. So again, you can try B and C on your own. Same idea. You want to be applying the powers, exponent laws, and then simplifying at the end. Okay. Let's go ahead to do a problem where we have some variables. So the last two examples, we only had numbers in them. Now we're going to be working with some examples where we have some variables as well as numbers. And I'm going to do the first two, and then if you want to try part C on your own, you can. Okay, so let's go ahead and do this here. 5x cubed, y to 5. Okay, so one thing to note when multiplying, so in the brackets here, we just have a bunch of multiplying together. However, all of these have different bases. We have a 6, we have an x, we have a y. They're all different. Same here, 5, x, and y. So none of those can be combined together. So there's really nothing to do within those brackets. So really all this is just a bunch of things being multiplied together. And when you multiply things together, you can do it in any order. So I'm just going to rearrange this and multiply all the numbers together, 2, 5, and 6. And then I'm going to put the x's together. All I'm doing is simply rearranging this equation, and then I'll put the y's at the end. Typically, we just go in alphabetical order. That's why I put the x's before the y's. But okay, and now 2 times 5 times 6, that's 60. For these two, I can apply the exponent law that says you add the two exponents together because I'm multiplying two powers of the same base. So -4 plus 3 would be -1. And finally, we're going to add these two together. So that would be 8. Now, what the question said, I didn't say at the beginning, but it said you always want to write your final answer with positive exponents only. So if you end up with any negative exponents, like we did here, -1, what you want to do is just flip that to the bottom. So we know a negative exponent just means divide by that number instead. So all we have to do is flip that x to the power of 1 in the denominator. Typically, we don't write a power of 1, so you can leave it off if you want, but it's not wrong if you leave it there. You just wouldn't see it in an answer key. So there we go. There's our final simplified version of that. So we only had to apply one exponent law in that question. In part B, we're going to have to apply 2 different exponent laws. We're going to do power of a power, and we're going to do the quotient exponent law. Okay, so squared 18x6 y to minus 7. Okay, so we're going to work with the bracket first. That's what BEDMAS tells us to do. Within that bracket, all the bases are different. This has technically a power of 1 on it. All the bases are different. We have a 3, an x, and a y, so none of them can be combined. However, I do have this 2 here. So what we can do is apply that 2 to every single term on the inside. So we're going to use the power of a power law and multiply all those exponents together. So I'm going to write my next step here so I have a little bit more space. So we'll have 2 times 1, which is 2. Some students forget to apply it to the number. You need to apply it to every single term, even the number. X to the power of 6, y to the power of negative 10. And then we have 18, x to the 6, y to the negative 7. Okay, so before I move on, 3 squared, I can actually just evaluate that. I'm going to erase it and put just 9 here, just because it'll be a lot easier to see. So let's think of each of these separately. We have 9 divided by 18. We have x to the power of 6 divided by x to the power of 6, and we have y to the negative 10 divided by y to the negative 7. So for this, the one highlighted in blue there's no exponents to deal with. It's just simply a division. 9 divided by 18 is 1/2. So that's 1 over 2. It can be reduced to 1/2. And then for these ones, we're going to subtract the exponents because we're using the quotient rule. So this would be x to the 6 minus 6. And this would be y to the negative 10 minus negative 7. So we would get 1/2 x to the power of 0, y to the power of negative 3. And we want to write our final answers with positive exponents only. And we have to remember anything to the power of 0 equals 1. So our final answer is going to be 1 over 2y cubed. So we flip the y into the denominator and make that exponent positive. The x disappears because that whole expression there, x to the power of 0, is equal to 1, so it's gone. Okay, and then if you would like to, you can try the third one on your own. It involves foiling, so you can try that. Okay, and then finally, we're going to do a word problem here. Check your understanding number 4. So there's not much space to do it, so I'm going to do it under here. And this word problem refers to this formula given in the example 4 here. So it says the height of a certain species of fir tree can be estimated by this formula. So a lot of different formulas in science involve exponents. And D is the diameter of the tree. And H would be the height. Okay. So let's just do 4A together. If you want to try 4B on your own, you can. So it says the base of a fir tree has a diameter of 4.5. Determine the approximate height of the tree. The word approximate here is your indication that you're going to be using a calculator for this. So I'll show you how to do that. So let's write the formula. So we're going to write it over here where we have some space. H equals 35 d to the power of 2/3. Use a different color here. And we're told the diameter is 4.5. So we're going to replace the d in the equation with 4.5. I won't be able to evaluate that exactly, especially because the question hints at that saying approximate and then give the answer to the nearest meter. So I know I'm going to be using a calculator for this. And BEDMAS tells me, so I've got a multiplication here between the 35 and the exponent, but BEDMAS tells me I need to do that exponent first. So I'm going to type in, sorry, my light's turned off, 4.5 to the power of 2 divided by 3. And you'll get 2.72568, ... It's going to be a decimal that continues forever. It's an irrational number. And then finally, you can just use that in your answer, just simply type times. So you don't have to like retype in that whole decimal, just type times 35. And you'll get 95.39883122. But we're just going to round it off to 95 because it said nearest meter. And notice I use this little dot on the top, meaning that it's not exact, it's like an approximate answer. And that's how tall the tree is. The tree is 95 meters tall. Okay, and that is the end of that lesson. I will stop the recording.